Hey guys, the Bamboo Labs marketing in recent years has been pretty effective on me, I'm not ashamed to admit. I've been lusting after a cool, fast, reliable, multi-material capable machine ever since their H2D launch. But for what little 3D printing I do, that one is too expensive for me, and their ecosystem too proprietary. But my old friends at Qidi Tech have just launched these two new machines, and the combination seemed just right for scratching that itch for me. This is their long-awaited Qidi box, multi-material magazine and filament dryer. And this is a new printer which they call Q2, a fully enclosed mid-range Core XY printer, with camera, active chamber heating, strain gauge bed probing, and what really matters to me, the Klipper firmware. I'm not sure if I could ever be happy again with a fixed, closed, limited, manufacturer-supplied printer OS. After having experienced Klipper's glorious open sourceness on a few machines, and the ultimate freedom to do everything with it. By using this firmware, manufacturers agree to inherit and carry on the openness of their source. And so another whole angle that made me optimistic about this system is the idea that eventually there could be a little universal software plugin that might make this affordable AMS alternative usable with every other Klipper out there. That, in addition to my insatiable hunger for new toys, is what led to this video. So let's see if this can live up to my expectations. As a first experiment, I'd like to pretend that I know nothing. Won't have to work hard for that. And then we can see if this product is suitable for beginners, which their marketing implies. There is a pretty lengthy initial setup routine, all automatic and sensor-based, so that's a good sign. At no point did it instruct me to check the bed leveling screws. It can presumably compensate for pretty large errors in those automatically. But one was completely loose, and I just prefer to have these set reasonably accurately, to let the bed mesh compensation do as little work as possible. This vibration benchmark is bundled with Klipper, so nothing we can give Qidi Tech credit for, but nice that they fitted an accelerometer into the print head to take advantage of this. In this sweep-through vibration frequencies, it detects resonance peaks, and it memorizes those for avoidance or compensation even in the future. Installation of the multi-material magazine is not trivial but manageable. There is a third intermediate device that needs to be plumbed in between printer and box. I suspect it's simply the 4-into-1 merger, and a filament detecting switch that helps the controller see up to which point the 4 filaments have to be shoved in or pulled out, to be ready or to clear the intersection for somebody else. The value proposition is obviously multicolor printing for visuals, but what I'm most interested in is technical stuff like water-soluble supports, embedding flexible sections into larger parts, or maybe even 3D circuits with conductive materials one day. Qidi Box is cheaper than Bamboo's offering, but availability seems to be limited currently. Crucially, the material compatibility list of Qidi Box is longer than that of the popular competition. It even includes some glass fiber reinforced filaments. But I would take this with a grain of salt. Yes, it's true, they are using more metal components and nice quality dual drive extruders per slot, which may resist abrasive materials for a long time, but they too are going to get slowly abraded. And I wouldn't count on doing many filament changes between such hybrid materials, because every change involves a cut with a fine blade, and that will certainly not hold an edge for many cuts into carbon fiber and glass fiber reinforced materials. So storage, drying, and automatic transition to the next spool when one is empty, yes, that sounds realistic. Frequent, routine changes between such advanced materials, hundreds of times per print, I don't think so. That I would do only with normal materials. After this video was shot, I thought I'd quickly take Qidi Box apart, and my god was it ever not quick. This is a very, very complicated assembly, and at $230 I cannot imagine that they are making a lot of profit on it. Quality of design and components in here seems very good for the price. It better be very, very good, no matter the price. Because this contains powerful heaters that many people will just leave on running overnight and when they are out of the house. If there ever was a serious enough malfunction, you'd have a fire on your hand, fed by up to 4 fresh, delicious kilograms of plastic. But no, at a superficial glance, this looks reasonable. I especially like that they have these 2 thermal fuses directly in series with the mains input. If they ever see an excessive temperature on the heater, they'll cut power completely. That's an additional 2 safety layers on top of the software control, which will behave similarly. And then I believe the heaters themselves are these ceramic PTC types. Their resistance rises with temperature, so they are inherently pretty safe, and self-regulating with the opposite of runaway behavior if all else fails. So that's one side of the story. It's nicely made. I like it. But holy moly, you better pray that there is never going to be a congestion in here, or the need for maintenance, because unloading all the filaments, for which there exists no pure mechanical shortcut by the way, the motors must be working and the printer connected to command them. Where was I? Oh yeah. Better pray that there is never going to be a congestion in here, because unloading and unplugging everything, taking this complex assembly apart, working on it, and then putting it all back together, will cost you an hour at least. In about a month of testing I had no such problems and I don't see any obvious weaknesses in here. But having been a 3D printerer for years, I kinda predict that this will give some unlucky users some issues. It's just in the nature of frequent handling of inhomogeneous materials, under the guidance of inhomogeneous users. 4 separate dual-drive extruders that are metallic where it matters are a solid solution, but unexpected things will happen in here is what I'm saying. This mini-geared drivetrain seems to be for rewinding filament onto its spool upon retraction from the Bowden tube. The unwinding during printing seems to happen over a freewheeling mechanism. Okay, back to testing. Qidi box will automatically grab and feed newly inserted filaments through its digestive system and all the way back to the hub. Doing so, it automatically learns about tube lengths and port pairing. That's convenient but very loud and rattly. Sounds like it's been doing this for 20 years and it's about ready to retire. It's just a freewheeling mechanism that does that. There is a component called Sprague Clutch which can do that silently for the next version. Not all spools are allowed in here. Non-standard widths and diameters not supported. Sunlu plastic spools like this one not supported. I can kinda see why. It seems to have a tendency to teeter or wobble rather than cleanly unrolling. Cardboard spools, by far the most popular type with cheap filaments now, not supported, and that is a real limitation to keep in mind. The noise easily penetrates the cover and ordinary interior doors too, so I would recommend positioning this far away from a human workplace. Oh, okay. Yeah, it really doesn't like that spool. There seems to be an RFID reader per slot for automatic recognition in the future, or DRM. But I don't have a genuine Qidi spool at the moment, and manual entry of the details is implemented very nicely. Only available through a modern Qidi printer UI. Standalone configuration of the heater set point, or reading of the humidity sensor, not possible currently. The supported printer needs to be there and powered on. I also just noticed, using Qidi box as a heater dryer automatically enables noisy internal circulation fans. Other standalone filament dryers can do their job silently, simply by heating the volume, no fans needed, in my humble opinion. Since we want the manufacturer's intended experience, and since there is a lot of non-standard stuff happening with that multicolor box anyway, I will use Qidi's own slicer software for now, where everything should be prepared for a nice beginner-friendly fire and forget experience. And yeah, it's actually pretty good. There are online features, by the way, for those who want them. You can have an account and a smartphone app, I guess to manage and monitor jobs remotely. But that's completely optional at this stage. I'm doing this all in my local area network without an account. You can automatically synchronize the filament details that we've just entered into the printer's display and have them available here for a realistic preview. Yeah, this is all easy. Not necessarily for grandma, but an enthusiastic beginner can certainly start this and succeed. So far. Only I'm not so sure why we are about to build this girthy, wasteful purge tower. Isn't that what we have a poop chute for now? Also, why is there a total print time prediction of over 1 day? For a super simple palm-sized little thing like this, that can't be right, can it? Oh boy, are we in for a lengthy surprise. Like, I'm not familiar with any other manufacturer's color changing capabilities. But my god, is this thing's default behavior incredibly slow. Here it's all in awkward real time for your enjoyment. It drives against a hard limit on the x-axis to actuate a lever and blade-based filament cutting mechanism, creating nice and clean edges directly above the extruder for reliable reinsertion on the next layer. The blade is another wear item that might not last long if it has to cut carbon fiber and glass fiber reinforced filaments hundreds of times in just a single print. The user has complete control over all G-code macros that direct this behavior. So, if such hybrid materials are intended to be used heavily, I could imagine developing a kind of cold or warm pull macro that tries to replace blade cutting with pulling a nicely formed filament end out of the nozzle at a certain suitable temperature. Maybe, no idea. For normal pedestrian filaments like PETG, which is what I'm running here, the blade is good. It takes no time at all, but it leaves a little rest of the old color in the extruder, which is what is being tediously defecated out into a little waste bucket in the rear wall. Like right now, as we speak. There must be so much in there. To be fair, in the meantime the multicolor box has to retract the old orange past the hub and then carefully thread in the new black far enough for it to reach the extruder gears. But that's only a matter of 20 seconds or so. What it's really taking its sweet time on is absolutely excessive purging. Like I've just watched it up close, and when my eyes thought that the new material was nice and clean and sufficiently pure, it still kept dumping for another 30 seconds or so. And then additionally, after that, it'll go to a purge tower and waste more. So yeah, this preset is not optimal, and the 44-gram penguin taking over a day of print time is insane but true. Quick butt wiping on a purpose-built rubber brush, so that we don't risk carrying any impurities to our purge tower. When I tried a mosaic palette multicolor box for my Cetus printer 7 years ago, there were already strategies for using purge material for invisible infill structures and supports. I sure hope those have matured and are available now. Hey, we are finally ready for another 18 seconds of actual layer printing, before going right back to another 2-minute material change. Some layers in this print have 3 different colors. The manufacturer teases cascading boxes for printing with up to 16 different filaments at a time. Oh no. The built-in time-lapse function works, but the camera's default resolution setting is laughable. It can be changed. They were also advertising with AI spaghetti detection, but I'm not convinced that that will work reliably at this resolution. Here's another time-lapse. Oh, this one is a bit unflattering. The result overall is very good, except for a few little overhangs which I had expected to be unproblematic. The chin could have used a little bit of support, just like mine when I saw this the next day. Yep, we wasted 348 grams of plastic for printing a 44-gram model. Yikes, let's all agree to not use the default settings on these. To be fair, Orca Slicer has a clever menu for adjusting color dominance dependent flushing volumes. And flushing into infills and supports is also an option. I had another problem with the unmodified standard slicer profiles. The resulting tux is gorgeous, 99%. The small overhangs that I had expected to be fine, that really aren't, indicate something more severely wrong though. Even on completely effortless models, there's something going wrong with the default PETG and PLA profile too. This is probably the worst offender. How on earth does this happen? But then a printed thread comes out okay again? It took a while to fix this, and that is not a beginner-friendly experience whatsoever. I'm not entirely sure what exactly caused it, but the very outer perimeter was often printed with an unsuitably slow flow rate of about 1/5 of a cubic millimeter. And I guess that goes hand in hand with the hot nozzle staying in one position for too long and overheating the whole neighborhood. I fixed it simply by copying all the overhang and slowdown related parameters from another machine. Q2's standard 0.4mm nozzle is capable of delivering over 20 cubic millimeters per second of PETG. That is nice and fast. In the default slicer profiles and macro behaviors, nothing else is. Let's quickly print this small screw to illustrate. The printer is homed and the build plate is preheated to its set point already. I will also disable time-lapse and bed mesh probing because I'm in a hurry. We should be ready to go with a regular spool holder on the side. No waiting for any multi-material box interactions either. And this will be my last point about slicer profiles. I mean, no printer I ever tried was delivered fine-tuned to perfection. Maybe the Prusas and Bamboos come close nowadays, but not these economy-class machines normally. I guess a part of this beginner-friendly intention is to be as autonomous and hands-off as possible. So they double and triple check everything very carefully, at the expense of time and material efficiency. Excuse me, why are we sitting on the poop chute again? Oh, of course, when heating up the hot end there could be a little bit of drooping. Traditionally that is taken care of with a little prime wipe off to the side somewhere. But I get it, we paid for the poop chute, so we want to utilize it. Quick, vigorous wipe on one brush. And here's a cool idea, I haven't seen that anywhere else before. The nozzle moves to a dedicated, perforated little ear. That's part of the magnetic build sheet, but extending over the plate slightly. So it's slightly springy and the nozzle can travel to Z-0.3mm without crashing. There it waits for the nozzle to cool down to 140 Celsius, and then it starts performing another slow, sensual wipe, which is probably meant to break off now solidified droopage. And then, of course, we proceed to a third wipe location, where we rid ourselves of some loose crumbs or something like that. What? Was that a filament cut? To my incredulous inquiry, Qidi Tech replied that this cut is made to prevent the loaded filament from influencing the bed probing performance. But I unchecked bed probing and the machine is homed already. Mom, are we there yet? Mom, can we stop at McDonald's? I need to go to the poop chute. Bruh, what are we waiting for? Yeah, looking at the manufacturer-specified machine G-codes. We've got this tool change to initial tool command, and that invokes all of this. That's where the unnecessary cuttings and purgings come from. That just needs to be put into a big old if block, only to be executed when needed. With that as is, every print, no matter if carefully prepared or not, takes over 7 minutes to start. Some of it is reasonable and cleverly implemented, like the extremely careful multi-stage nozzle cleaning. It's using the nozzle tip itself and the load cell for bed probing, so perfect cleanliness is vital for a good repeatable first layer. But on the other hand, there's a confusing mixture of machine G-codes in the slicer and Klipper macros, with partially overlapping functionality and multiple hard-coded 30-second delays, and redundancy in some steps. Yeah, I don't know, it's neither here nor there. It works mostly, it's inefficient. But a power user can go in there and optimize it so that it behaves like this. It will probably be an affordable printer, so it's all good. My own preferred workflow is to preheat the build platform a long time in advance, manually, so that it's settled and finished thermally expanding for the auto probing. For even better time efficiency, I like to use KAMP, Klipper Adaptive Meshing and Purging, already installed on Qidi Q2, just not used, for reasons unknown to me. It lets us probe only a region of interest underneath a planned print, not the whole board every time. And then, having done a volumetric flow benchmark, we can really speed things up, pedal to the metal, without any quality degradation. That's what these Core XY beasts are supposed to sound like. Oh, by the way, cardboard spools can be used after all, with these adapter rings intended for bamboo AMS. With maximized volumetric flow, I made this huge 2-part koozie with a Peltier-shaped hole in the bottom for TCR testing of a special resistance standard. And with a cubic infill structure, which seems to be a pretty effective thermally insulating closed-cell foam. This is a good runtime for a couple of small parts. And a couple of small technical parts is what I usually use 3D printing for. I don't do large volume mass production. And I don't do large volume prints either, so this machine's build plate size seems suitable. Geometric accuracy is good. I can make holes that M3 threads bite into reliably. And I can make fully correctly shaped M10 threads. This is going to be a constant tension wire unroller, and you'll hear more about it soon. The hot end system performs very nicely. It can reach high flow rates and high temperatures, I think up to 370 degrees Celsius. But the nozzle seems unusual. I'm not sure if you'll be able to just buy one locally quickly. We'll have to hope and rely on Qidi to sell these for as long as the machines last. The dual drive extruder seems like a good quality part, and it's nicely accessible and uncloggable. My previous flash forge printer needed a 20-minute disassembly to get to those. I believe it's suggested that the multi-material box be placed on top of the printer. I'm not sure yet what the input shaper is going to think about that, and if it can still counteract vibrations at maxed out acceleration values of such a top-heavy assembly. If so, it's going to be a wonderfully space-efficient combo. Such compactness comes at a cost though. There is a pretty tight bend in the filament tube, and it rubs against the mounting screws in the handle. No big deal, I'll remove the handle. Let's see what Klipper's input shaper has to say about all this. When launching that tool, we get some verbose output in the fluid web interface console, and everything is applied and saved automatically upon completion. But if we want to know more, we can also SSH into the printer, username MKS, password makerbase, and then we can grab some temporary CSV files with the new results. A Python script in the Klipper project can generate these nice illustrations out of them. We are being recommended the EI shaper and accelerations below 3600 mm per second squared. Q2 is advertised with 10,000 mm per second squared accelerations. So this is not good, but if we comply with this recommendation, we would get nice performance out of it. To get closer to the datasheet spec, I added some sketchy cross-bracing to this weak old wooden table. And when that did nothing, I just bolted it to the wall. I also put the printer on a huge heavy granite plate. In combination, these two measures improved the low frequency range slightly, similar to what standing on the floor would do. The frequency range of interest seems to be in the low hundreds of hertz, and for that I found tensioning the belts much more effective. In the spirit of beginner friendliness, the printer can almost do that itself. These rear pulleys seem to be spring-loaded, and when loosening them they adjust themselves. Except not quite to the optimal tension. When plucking two equal length sections of the belts, like guitar strings, it's most important that they are playing the same notes. And for optimal vibration shaping performance, they need more tension and higher notes. Nothing too excessive, that would also not be good. I just set them both to about 100 Hz. And that helped massively. We are now being recommended different shapers, and indeed the 10,000 accelerations. As promised, for both axes, and no matter if the multi-material box sits on top or not. Nice. This machine uses 1.5 GT belts, which are a bit beefier than what Prusa Core 1, for example, uses. But these two have to be retensioned occasionally, especially when new. Build plate flatness seems fine for what it is, 0.3 mm peak to peak, worst case. Better if we don't need the very outer corners. Subjectively, I don't like this double lead screw situation. It allows this kind of twist in the plate, but practically it will experience very low forces in normal operation. So it's fine, I guess, but 3 lead screws would have been nicer. Let's see if we can print something in polycarbonate to really flex all the heater capabilities of this machine. and hopefully not see the first few layers flex while the print is still ongoing. This is one of the most notoriously warpy and poorly adhering materials, but mastering it would be worthwhile due to strength and great environmental compatibility. It's supposed to be supported based on the manufacturer's pamphlets, but a custom slicer profile has not yet been prepared, so I guess we are YOLOing it. The enclosure starts creaking and crackling a bit when first experiencing the 100°C build plate and the 65° active chamber heater. But for this being literally my first attempt, it's doing a nice job, I think. There is some warping of the corners, but nothing catastrophic. I'm certain that this can be fixed with some hairspray and a wide brim. Yes, I would say Q2 is up to the task when given a little bit more careful preparation. Yeah, overall this thing gets a seal of approval. I like it with a few footnotes. And many of those are likely to be fixed shortly. And that's all. Thank you for watching.